I want to work on some calculus problems where we talk about the definition of Taylor and Maclaurin's series. All right, so that said, I got a lot of problems, so let's just jump right into it. What I have is I've got this definition here, and basically what it says is the idea of this topic is this topic rewrites what are common functions. It takes a common function and it rewrites that common function in the form of what we'll call a power series. It'll take this common function and you'll be able to rewrite this common function as an infinite series, a series of terms that the more terms that you have, the more terms that you possess, the more accurate the polynomial is to the common function. So sometimes it's not as clear saying it. I think what we should do is just actually do some problems, and hopefully what I'm saying will be clear. So let's do that. I've got this problem where we have the function f of x is equal to x to the negative 2, but we know that that's the same thing as 1 over x squared. So that's some common function, all right? So maybe you've seen that in your algebra class. I'm certain you've seen it in your Algebra 2 trigonometry class. But what we want to do is we want to rewrite this very common function as a power series or as a polynomial, as an infinite series. And the way we're going to do that is to look at this definition of the, oh, by the way, they say rewrite this as a nth term in the Taylor series about x is 1. All right, so about x is 1. All right. So the best way to go about this is to determine what a lot of these terms are. So this f of c, what that means is just take the original function, which was f of x. F of x is 1 over x squared. And if you want f sub c, that's just the same thing as f sub 1. That's just the same thing as f sub 1. So what you'd have is 1 over 1 squared, which is just 1. So f sub c is 1. All right, so you'll need to keep going. We'll also need f prime sub c. Well, f sub x was x to the negative 2 power. So f prime sub x would be negative 2x to the negative 3 power. That simplifies to negative 2 over x to the third. So that's f prime sub x. So f prime sub c, or in our case 1, would be negative 2 over 1 cubed. This is negative 2 over 1 cubed, which is just negative 2. So f prime sub c, or in our case, for our problem, f prime sub 1, that's negative 2. F sub 1, that's 1. So you'll discover a pattern with all of these problems. It might, oh, I'm sorry, you can't see that. All right, so you'll discover a pattern. It might be confusing at first, but to some degree, this is somewhat of a problem where you're just doing a lot of calculating and substituting into this definition format here. So let's figure out what f double prime sub x is. All right, so we know that f prime sub x is negative 2x to the negative 3. F double prime, or the second derivative, would be 6x to the negative 4, which is the same thing as 6 over x to the 4. That's the second derivative. And if you evaluate this, f double prime at c which is what you need, all right, you'd evaluate the second derivative at 1. So what you end up with is 6 over 1 to the 4th, which is just 6. All right, so that's f double prime sub c. All right, so what you're going to discover is what I'm going to do is I'm going to rewrite this definition of the Taylor series. All right, definition of the Taylor series. If I were to rewrite it, say the polynomial, and again, this polynomial, what this polynomial represents is it's going to be a polynomial that you're rewriting this series as a polynomial. This is a very, very standard series, and you're rewriting this as an infinite series or as a polynomial, an infinite polynomial. All right, so we get p sub x is equal to f sub c plus f prime sub c times x minus c plus f double prime sub c times x minus c, and don't forget for us c is 1. That's squared over 2 factorial, and this goes on and on and on. One of the things that I've been trying to say to you is you can have, the next term would be f triple prime sub c times x minus c to the 3rd power over 3 factorial. Hopefully you see the pattern here. This is f of c times x minus c to the 0 power over 0 factorial. This is f prime sub c times x minus c to the 1 power over 1 factorial. Hopefully you see the pattern here. And again, you could have an infinite number of these terms as you'd want, depending on how accurate you want this approximation to be of your original function. All right, so let's begin substituting this stuff in. All right, so our polynomial function, p sub x, is f sub c, which we said up here was 1. F sub 1 is 1. So we get 1 over 0 factorial. Well, that's 1. By definition, 0 factorial is 1. So we just end up with a 1 here. So we get 1 plus f prime sub 1. We figured that out already. That was negative 2. That was negative 2. So what we have negative 2 times x minus c. C was 1 for us, over 1 factorial. 1 factorial, that's just 1. All right? So we have plus what we have is the second derivative evaluated at c. Well, we did that already. That was for us 6. So we have 6 times x minus c. For us, c was 1. So we get x minus 1 raised to the 2nd power over 2 factorial. 2 factorial, that's just 2 times 1, which is 2. And now we didn't determine the 3rd derivative, but we can do it over here. F triple prime, the 3rd derivative of x. We already have the 2nd derivative, which is 6x to the negative 4. The 3rd derivative would be negative 24x to the negative 5. Negative 24x to the negative 5. All right, so now f triple prime sub 1 would be, this is the same thing as negative 24 over 1 to the 5th power. So you end up with negative 24. So you end up with plus f triple prime sub 1, which is negative 24 times x minus 1 to the 3rd power over 3 factorial. That's 3 times 2 times 1, which is 6. All right, so now all we're going to do is just simplify all this. All right, so we have p sub x is equal to 1 minus, let's just distribute that. We get minus 2x. Well, I don't know. Let's just keep it the way we had it. Plus a negative 2x, negative 2 times x minus 1. There's a couple ways you could write this. That's what I'm hesitating over. All right, so I just said plus a negative 2. I'm just rewriting what I have here. I just brought that down. So there's no difference between this and this. Plus 3 times x minus 1, because 6 divided by 2 is 3. That's squared. Minus 4 times x minus 1 to the third power. All right, and we could go on and on and on. It's an infinite series of terms that represent 1 over x squared. All right, so that's basically what this is all about. This is an approximation. This is an approximation, a very, very good approximation of this common function, f of x equal to 1 over we had x squared. P sub x was equal to this series here, and this was a representation of f of x. F sub x was equal to 1 over x squared. All right. So this is a representation of this. So this was centered about 1. This was centered about 1. So let's try it again where we want to figure out what f sub 1 point, let's say 2. What's f sub 1.2? All right. And we end up with 1 over 1.2 squared. 1 over 1.2 squared. And you end up with 1 over, so let's put that in the calculator, 1.2 squared, that is 1.44. This simplified, take the reciprocal, and you end up with 0.694 repeating. All right, so that is the actual value of f sub 1.22, or excuse me, 1.2. And what I'm trying to communicate to you is that we rewrote, or this is an approximation. It's a series that represents an approximation of f sub x, of this function 1 over x squared. And what I'd like to do is I'd like to figure out what p sub 1.2 is, figure out what p sub 1.2 is, and compare it to the actual value of f sub 1.2. All right, so if we did that, we'd end up with 1 minus 2 times 1.2 minus 1, that's to the 1 power. And then we have plus 3 times 1.2 minus 1 to the 2nd power. All right. And then we have minus 4 times 1.2 minus 1 to the 3rd power. And we want to compare this to the actual value of f sub 1.2. All right, so let's put this, let's just simplify this a little bit. So we get 1 minus 2, and then we end up with 0.2. All right, 0.2 plus 3 times 0.2 to the 2nd power minus 4 times 0.2 to the 3rd power. All right, let's figure out what that is. All right, so we get 1 minus 0.4, 1 minus 0.4, all right, 2 times 0.2 is 0.4, and we end up with plus 3 times we get 3 times 0.04, 0.2 times 0.2.04, and minus 4 times 0.04 times 0.2, 0.008. All right, so I just took 0.2 times itself 3 times, got 0.008, and we end up with 1 minus 0.4 plus 3 times 0.14, that's 0.12. All right, 0.12, and then we end up with minus 4 times 0.008, and you end up with 0.032, and then you would just use a calculator to bring all these terms together, combine all of this, and get our approximation of f sub 1.2. So we end up with 1 minus 0.4 plus 0.12 minus 0.032, and we end up with 0.688. All right, and what I'd like you to be able to see here is this is an approximation. We got this from figuring out our series approximation, a Taylor series approximation, and we substituted in the 1.2, and notice how close that is to 0.694, which is the actual value of f sub 1.2. Look how close this is. All right, so that's what this is a study of. And again, I want to, I said this, and I know I've said this a couple times. If we were to have a 4th degree Taylor series or 5th degree Taylor series, you would discover that this approximation would get closer and closer to the actual 0.694. All right, so that's what this is a study of.